Okay, so we are going to start the fourth lecture on unit number 2, and we are in the search techniques. So we have seen uninformed and informed search techniques, and the last lecture we have seen heuristic search techniques. So in this case, in heuristic search techniques, we have seen why we need the heuristic search. That is, heuristic search is used in the situations where there is a requirement of a short-term solutions. Then most of the heuristic methods involved mental shortcuts to make decisions on the past experiences. Then based on the context, we know that there are different heuristic methods that can correlate the problem scope. The most common and heuristic methods are trial and error, guesswork, the process of elimination, and historical data analysis. Then we have also seen the types of the heuristic search, that is nothing but representative search, effect search, availability of heuristic. Then we have seen there are different methods that can be used under heuristic search techniques. They are hill climbing, constraint satisfaction problems, simulated ailing, best first search. And as far as two categories are concerned, there are two categories of heuristic search in AI. They are direct and weak. So in case of a direct, it is also called as a blind search. It is an uninformed search, as well as it can be called as a blind control strategy. Research techniques are not always possible as they require memory, much more memory and time. Then the examples of the direct heuristic search techniques may be BFS and DFS. Then we have seen about the weak heuristic search techniques. They may be including like informed search and heuristic control strategy. Then they can be useful as they can be applied properly to the right types of the task, and they usually require domain specific information. Then we have seen in detail about various methods of the heuristic search techniques. And this first one is called as the hill climbing. So we have seen why it is called as a hill climbing. Okay, as it terminates when it reaches to a peak value when no neighbor has the higher value as compared to the node that is been chosen. It is widely used when a good heuristics is available. Then why it is called as a hill? Because it continuously moves in the direction of increasing elevation or value to find the mountain's peak or the best solution to the problems. The best example of the hill climbing is traveling salesman's problem. And it is also called as a greedy local search as it only looks to its good immediate neighbor state and not beyond that. These are the steps that are involved in heuristic search techniques. That is nothing but the algorithm. Then we have seen second method under heuristic search techniques is a best first search. It is the combination of a depth first search and breadth first search algorithms. As it takes the benefits of both the algorithms, it uses the heuristic function and search. With the help of the best first search, at each step, we can choose the most promising nodes. Then this is the algorithm that comes under best first search. So here there are two types of list, open list and closed list. So if the open list is empty, it will actually return, it will stop and return to the failure. And when a new node or a successor node is found, then it is to be taken under open list. If it is there in the open list or closed list, at that time it will add to the open list if it is not found. So this is how the best first search algorithm will work out. Then we have A star search algorithm, which is quite similar, which we have seen in uninformed and informed search techniques. It is most commonly known form of a best first search. It has a heuristic function h of n and a cost function from the start state g of n. It finds the shortest path through the search space using heuristic functions, and it expands fewer search trees and gives an optimal results faster. So this is the A search algorithm which has been there. So again, it will be working in the similar way. Only there are two differences here. The first one is that if the node is from the open list, then it will have the smallest value of the evaluation function called g plus h. In that case, it was h of n. Whereas the other one is that if you have a successor node, then it will check whether it is an open list or a closed list. If not, then it will go into the open list. And if the node n is already present in open and closed list, then it will give the lowest value of g of n dash. That is nothing but, and it will return to the, that is nothing but step number 5, and which will return to step number 2. So this is how the algorithm of A star search algorithm worked out. Then we also saw the simulated ailing, the examples of the heuristic search in everyday life. So we have seen some of the examples like common sense, rule of thumb, working backward, then availability of heuristic, familiarity heuristic, and educated guess. Then we also have seen types of heuristic search, as each of the heuristic types plays a very crucial role in decision making. So although there are various types of heuristic, but most of them include availability of heuristic, effect heuristic, and representative heuristic. So then we have seen the availability of heuristic. Then second, we have seen a representative heuristic with an example, like example of packing, product packing. We have seen the example of product packing. And then the effect heuristic. So this is nothing but the example of advertisement as far as the effect heuristic is concerned. That is playing with the emotions, and the emotions can tend to take wrong decisions at a time. So this is how the heuristic search techniques we have seen. Then there is an effect heuristic, which we have seen. There are limitations of this heuristic technique. The limitations includes the speed of decision making process. Although it helps to solve the problems, but it may introduce errors. Just because something is accurately done in the past, it means that it may not work in the present. Then it will be hard to find the alternative solutions or ideas if we rely on the existing solution or heuristic. So there are mostly two types of limitations as far as heuristic search is concerned. And the last type or the method of heuristic search technique is called as the constraint satisfaction problem. So the best example of the constraint satisfaction problem is the Sudoku game. So it is a problem that requires its solution within some limitations or conditions, and that is also known as constraints. So you know that what type of constraint occurs in the Sudoku. We have seen the complete example of the CSP. This is how the mathematical formulation is about the constraint satisfaction problem, and it is explained with the help of Sudoku problem. Some of the popular problems with CSP beyond Sudoku are the crypt arithmetic, that is coding alphabets to numbers, NQueen, map coloring, that is coloring of the map, crosswords, then Sudoku is the game a number grid, and then Latin square problem. These are some of the popular problems that are being dealt with CSP. CSP can be also considered as a research problem. So that is nothing but finding the ones that satisfy all the constraints in the search problems, like finding the shortest path between two nodes in the graph. So this is how the CSP is also understood. So now we are going towards a different search method. So we have seen heuristic. So there are some limitations of the heuristic also. So to overcome those limitations, again, one more search method has come into the picture, and that is called as the stochastic search method. Now, the stochastic search method is quite a popular method actually in machine learning also. We have a stochastic algorithm there also to find out the minimum optima. That is the local minimum optima. Now here, stochastic search method is actually a choice for solving many hard combinatorial problems. So you find there are some of the problems which can be solved in combined. So in these cases where you have a problem with inherent random noise or a deterministic problems, then we can go with the stochastic search. The search favors designs with better performance, The most important feature of this algorithm is that they carry out broad search of the design space and then avoid local optima. So I've said that it is mostly been used find out the minimum optima. Also, the stochastic search algorithms do not require gradients to guide the search. So stochastic gradient की जरूरत नहीं, वहां पर actually machine learning में stochastic gradient use होता है जो कि minimum optima ढूंढने के लिए काम में आता है. मगर इस केस में stochastic search में आपको gradients की जरूरत नहीं है in order to go for a search. They are actually very good fit for discrete problems because of this thing. However, there is no necessary conditions for the optimal solutions, and the algorithm must run multiple times to make sure the attended solutions are robust. So obviously it will be executed multiple times in order to get a better solution, in order to achieve a better solution. And it is also called as a robust method. Why robust? Because even if you can run for longer time, it will not have any kind of effect on the results. It will try to give a better attained solutions in order to ensure that you will attain solution. So stochastic search is a very good method that could be used where there is no necessary condition for an optimum solution. This is the most important line. Otherwise, what happens, the earlier search methods, we have seen that they were actually going for the optimum solution. But here there is no necessary condition for the optimum solution. So that is the difference between the stochastic search and the earlier search, what we have seen. That may be informed, uninformed, or it may be heuristic search. Stochastic search algorithms are also called as randomized search heuristics. So they are also called as heuristics, but they are randomized. Are general purpose optimization algorithms that are often used when it is not possible to design a specific problem for the problem at hand. Well-known stochastic search algorithms are random local search and simulated ALING. So obviously the randomness will come into the picture. Whatever we have seen in the earlier methods, like in heuristic, this is also one of the heuristic methods, search, but it is also called as a randomized search heuristics. So when it is to be used, when it is not possible to design a specific problem or a specific algorithm for a problem at hand. So at that time you can use stochastic. The well-known stochastic search algorithms that can be used are random local search and simulated ALING. So these are the two algorithms that comes under stochastic search in order to implement. Other more complicated approaches are inspired by the process observed in the nature. So most of the things that been observed from the nature has been helpful in designing these kind of search algorithms. So what are the stochastic search algorithms popular examples? Like we have seen about heuristic where they can be used. So there are some of the popular examples of stochastic search methods, like an evolutionary algorithms which has been inspired by the natural evolution. यानी वो क्या बोल रहा है कि आपके नेचर से वो थोड़ा सा इंस्पायर्ड होता है और फिर बाद में वो आर्टिफिशियल तरीके से जैसे नेचर को ऑब्जर्व करके वही आर्टिफिशियल तरीके से करने की कोशिश करता है स्टोकेस्टिक सर्च एल्गोरिथम. सो ऐसे कोई एल्गोरिथम्स है जो नेचर से इंस्पायर्ड है और वो पॉपुलर एग्जांपल जो है वो स्टोकेस्टिक सर्च मेथड्स के अंदर आते हैं और वो है एवोल्यूशनरी एल्गोरिथम्स विच इज इंस्पायर्ड बाय द नेचुरल एवोल्यूशन. सो आप देखते हो कि नेचर में एक एवोल्यूशन है, एक दूसरे पे डिपेंडेंट है और हम इवोल्यूट हुए हैं. तो उसी से वो एक पॉपुलर एल्गोरिथम उन्होंने बनाया कॉल्ड एज एवोल्यूशनरी एल्गोरिथम. नेचर से उन्हें ऑब्जर्व किया एंट कॉलोनी ऑप्टिमाइजेशन. सो हाउ द एंट बिल्ड द कॉलोनीज. So based on that, inspired by the ant foraging behavior and artificial immune systems, inspired by the immune systems of vertebrates. So there are different algorithms that have been inspired, which comes under stochastic search from the nature. So it is actually heuristic search technique is only, but it is a randomized heuristic search, and that has been oftenly used for general purpose optimization algorithms. and oftenly used when it is not possible to design a specific algorithm for a problem at hand. यानी आपके हाथ में एक algorithm है और specific आप उसके लिए solution नहीं मिल रहा है अचानक, तो आप वहां पर stochastic search का इस्तेमाल कर सकते हैं. The main advantages of the stochastic search heuristic is that being general purpose algorithms, they can be applied to wide range of applications without require hardly any knowledge of the problem at hand. So obviously it is an heuristic search, but at the same time it is a general purpose algorithm, and they can be applied to a wide range of applications and no need to have a knowledge of the problem. So that's the main advantage of this. Otherwise, what will happen in number of situations where you're going to use number of different search techniques, you required some kind of information about that situation. But this stochastic search doesn't require, normally doesn't require knowledge of the problem at hand. In particularly given a stochastic search problem, it is unclear on which kind of problems it will achieve good performance and on which it will perform poorly. So obviously we cannot judge how well this stochastic search algorithm may operate, may offer on different applications. It is possible that it may give a good performance, or sometimes it may give a very poor performance. So there is no guarantee that it will perform good every time. So you may have that kind of variations in the performance. Even more crucial is the lack of understanding of how the parameter settings influence the performance of the algorithm. एक और चीज है कि beyond that कि भाई वो गारंटी नहीं देता है कि वो हर बार उसका परफॉर्मेंस अच्छा ही रहेगा, कभी कभी पुअर भी हो सकता है. उसी तरह से वो पैरामीटर्स जो अप्लाई कर रहे हैं in order to understand the performance of the algorithm, there is also lack of understanding how these parameters influence the performance of the algorithm. How it affects the performance of the algorithm, it will never tell you. So there are some of the things which are very good for stochastic, but again, you know that there is always two sides of the coin. So one is good and the other one is having something limitations or having some kind of drawbacks. So it also have a drawback. It's very good. It's a general purpose algorithms, widely used, doesn't require much of the information about the problem that is been in hand, but at the same time have some problems that it will give you good performance or may poor performance. And second of the drawback that comes under is that we don't have that kind of we will be having lack of understanding regarding which parameters have affected the performance of the algorithm. The goal of a rigorous theoretical foundation of a stochastic search algorithm is to answer questions of this nature by explaining the success or the failure of these methods in practical application. But yes, it will try to give you the answers to the questions when there is a failure or when there is a success for a particular application. So obviously the goal of this stochastic search algorithm is to give answer to those questions which can help you to find out why it is successful or why it is failure in a particular applications. So these are some of the things that stochastic search algorithms have good in them, as well as some of them are having some issues also. From this perspective, an algorithm should be correct. That is, for every instances of problem, the algorithm halts with correct solutions, and it should be efficient in terms of its computational complexity. The algorithm uses the computational resources wisely. So as you know that as far as the perspective of the algorithm is that it should be correct for every instances of the problem. Then the algorithm should also halt with the correct solution that maybe give a correct output. And it should be also efficient in terms of computational complexity. Out of these all things, stochastic search algorithms are very wise in this sense. So these algorithms uses the computational resources very wisely. So there are some conditions out of which we can say that yes, the computational resources are very used widely. The resources usually considered are number of basic computations to find the solutions and the amount of memory required. So for what purpose these computational resources are wisely used? In order to find out the solution, that is time, and the amount of the memory required, that is space. So for these things, it uses the computational resources. Differently from problem-specific algorithms, the goal behind general-purpose algorithms such as stochastic search heuristic is to deliver good performance independently of the problem at hand. So the main task of this stochastic search is to give a good performance independent of what the problem is in your hand. Obviously, the most important thing is when you're going for any kind of search method, you need to get a perfect solution. Then whatever may be the problem in your hand, you try to achieve the maximum solution, or I could say that culmination, that is reaching to the highest development. In other words, a general purpose algorithm is correct if it visits the optimal solution of any problem in a finite time. So what is the condition? How can I say that my stochastic search algorithm is going good? So obviously the general purpose algorithm is said to be correct if it has an optimum solution of any problem, that to infinite time. Just having an optimum solution is not enough. You have to find the solution in time. And that is nothing but the perfect search method is set to be as finding the optimum solution of any problem in finite time. And it does that. Stochastic search does that. If the optimum is never lost afterward, then stochastic algorithm is set to converge to the optimal solution. Suppose if it is giving a very optimal solution, that too in a finite time, and if this optimum is never lost afterward, then we say that this algorithm is to converge to the optimal solution. So we can say that this algorithm is nothing but it is a converge to the optimal solution. So have you got this stochastic? Once again, I will recall some of the points. The stochastic algorithms is used wide range of applications without regarding knowledge of the problems in hand. This is the first time option, first point. Then second thing is that it is very much unclear that it will achieve good performance or it may perform poorly. Then the third problem that there is also lack of understanding how these parameters are affecting the performance of the algorithm. Then the fourth point is that the stochastic search algorithm will be able to answer your questions by explaining the success or the failure of these methods in practical applications. Then as we know that in most of the algorithm, they should be correct for every instances of the problems. They should give a correct solution, and they should also have an efficient computational complexity. So obviously stochastic search algorithm uses the computational resources wisely. Now next point is that how it uses the computational resources wisely. They uses the computational resources wisely in order to find out the solution, that is time, and amount of memory required, that is space. Obviously, the most important goal behind the stochastic search is to deliver good performance independently of the problem that is in the hand. It is a general purpose algorithm and it is correct if it finds the optimal solutions in finite time. And the last is that if this optimum is never lost afterward, the stochastic search algorithms are said to be converged to the optimal solution. These are the most important points of the stochastic search. In a formal sense of later condition, for convergence is required because most search heuristics are not capable of recognizing when an optimal solution has been found. Now let's little bit go back to understand the same point. That is, if the optimum is never lost afterward, then stochastic search algorithm is set to converge to the optimal solution. इसका मतलब अगर वो optimum solutions पा लेता है और उसके बाद वो continuously उसको रखता है पाकर, यानी कि वो never lost afterward. Then we say that this stochastic search algorithm is converged to the optimal solution. Now, why this convergence is required? This convergence is required because most of the search heuristics are not capable of recognizing when the optimal solution is found. ये पता ही नहीं चलता उनको कि optimal solutions कब मिल गया है. इसका मतलब they do not halt. They should halt if they found an optimal solution. Even if they found optimal solution, they should halt, but they are not halting, and henceforth, the convergence condition is always required. Understanding. However, it's success to keep track of the best found solution during the run of algorithm, and hence the condition is trivially to satisfy. But yes, it always keeps in track of the best found solution when the algorithm is executed. But the convergence is required because it doesn't know when the optimal solution has been found. And if the convergence has been required, and if the convergence has been taken into consideration, and then this heuristic search is implemented, then they can come to know that optimal solution has been found. So they can keep the track of that optimal solutions. What is particularly relevant and what can make a huge difference on usefulness of the stochastic search is its time complexity. So obviously there are two factors that comes into the picture. So what is the huge difference between these types of search, stochastic search, and the other type of the search method is the time complexity, right? Because here we have to achieve it within a finite time. In each iteration, the evaluation of the quality of solution is generally far more expensive than its other algorithmic steps. So obviously, in order to, in each iteration, if you go for the evaluation of the quality of solution, then it is considered to be as more expensive as compared to the other algorithmic steps. So evaluating the quality solution is a more expensive step as compared to the other steps. As a result, it is very common to measure time as number of evaluations of the fitness solution rather than counting the number of basic computations. So obviously, you're measuring the time as the number of evaluation of the fitness function, then counting number of basics of computations. यानी कितने बार ये हो रहा है, कितने बार compute हो रहा है, इससे better ये है कि कितने देर में वो हुआ है, ये जरूरी है ना? कितने steps में वो compute हुआ है, कितने computing steps उसने लिए है, ये count करने के बजाय कितने देर में वो compute हुआ solution. This is the most important thing as far as stochastic search is concerned. Since a randomized algorithm make random choices during their execution, the runtime of the stochastic search A to optimize function F to get the random variable T A comma F. So अभी अगर इसको mathematically हम लिखे कि stochastic search algorithm को हम randomized heuristic search algorithm बोलते हैं, बराबर ना? मैंने स्टार्ट में आपको क्या बोला कि स्टोकेस्टिक सर्च ह्यूरिस्टिक सर्च जैसी ही है, सिर्फ फर्क क्या है, रैंडमाइज पिक्चर में आ गया है, रैंडमाइज. सो फॉर दिस रैंडमाइज एल्गोरिथम, if I want to get a random variable, because I need a random function there, so how for this stochastic search algorithm, how you're going to find out a random variable? So obviously when there is a heuristic search A which is used to optimize a function F, then we get a random variable T A comma F. Now T A comma F is the most important parameter as far as this is concerned. Now when it comes into the picture, how we are going to find out the things, what are the interesting things that comes under stochastic search methods? The first is the expected runtime. जैसे मैंने बताया ना कि इसमें टाइम बहुत इंपॉर्टेंट है, कितने स्टेप्स ले रहा है कंप्यूटेशंस के, इससे बेटर ये है कि उसका रन टाइम कितना है. So how this runtime is expected runtime calculate hoga? Obviously by using the random variable which we have got as T A comma F. So how this expected runtime is given? It is given as E into bracket TA comma F. The expected number of fitness functions evaluations under the optimum of F is found. So with the help of this expected runtime ETA comma F, we are able to find out the expected number of fitness function in order to achieve the optimum of F. What is F? F is nothing but function. So in order to optimize this function, you're going to find out the expected runtime, which is nothing but expected number of fitness function. And if we do this, we can find out the optimum of F. Now we can understand from this diagram about how this stochastic search actually works out. If you look at the figure, this figure is actually drawn instance sizes versus the runtime. So obviously the expected runtime is calculated. There are two lines we can see here is the one is the red line and the other one is a blue line. Now, can you guess which is the efficient characteristics? Can you guess that which characteristics is an efficient characteristics? When I say that it is an efficient characteristics, the blue line. How? For skewed runtime distribution, the expected runtime may be deceiving measure of the algorithm performance. Obviously, runtime is going to decide your algorithm performance. The following measure therefore provides you the additional information. So how it has been helping you to find out that which of your algorithm is good as far as the expected runtime is considered. तो ये है कि अचानक से अगर अचानक से टाइम में आपका टर्मिनेट हो जाता है एल्गोरिदम और लंबे समय के लिए आपको वही परफॉर्मेंस देता है, तो ऑब्वियसली कौन सा ग्राफ आप प्रेफर करेंगे? द ग्राफ विच विल गिव यू द गुड परफॉर्मेंस फॉर अ लॉन्गर रन टाइम. Same exactly happens here. You can see in the figure there are two lines. One is a blue line, the other one is a red line. Now an efficient heuristic blue line versus an inefficient search heuristic red for a given instance. एक particular instance के लिए अगर ये run time blue अगर चलता है तो वो efficient result देता है as compared to the red. So this will give you a clear idea that how runtime is important as far as stochastic search is concerned. Both are important. One is your runtime and the second one is the space. That is nothing but the memory utilized. So this could be very clearly explained with the help of this diagram. This is the first point. Now, second point of this figure will give you little more idea about the time. Actually, the expected runtime has to be very good if it's to perform for the longer runtime. But now what happens is that you have to get the other point also where you can understand the success of the probability in T steps, right? So if you want to understand the success probability, we can do it in a T steps. So now you were having earlier as expected runtime of TA comma F. But instead of that, if we are going to get the success probability in T steps, then we can write down as PR TA comma F underscore T. Now in this function F is coming into the picture, right? Then you are having an A as an heuristic search, and then time is nothing but within T steps, right? So the probability that is optimum is found within T steps. So आपका optimum solutions कब मिलता है और कितने वक्त में मिलता है, तो वो जो steps हम निकाल रहे उसको बोलते हैं T steps. So you will be seeing here one parameter that is getting added here is T. This is the small t. So T steps can be calculated, which is nothing but the success of the probability with the help of TA comma F underscore T, which will give you the probability that optimum is found within T steps. A search heuristic is said to be efficient for the function class f if the runtime grows as a polynomial functions of the instance size. So दिख रहा है कि polynomial function, this is the polynomial function. So heuristic A is said to be efficient. ये A जो है वो efficient है. कब बोलेंगे हम लोग? जब वो एक function f के लिए निकाला जा रहा है. This is the heuristic search. This is the function f if the runtime grows as a polynomial function of the instance size. On the other hand, if runtime grows as an exponential function, the heuristic is said to be as inefficient. तो यहाँ पर कौन सा exponential है? ये वाला exponential. अगर वो exponential गया तो समझ लो कि वो inefficient है. अगर वो इस तरह से गया तो वो efficient है. So इस तरह से हम stochastic search algorithms को समझ सकते हैं. So there are few important points that comes under stochastic search algorithm which are not there in other types of algorithm. So I hope that you have understood this stochastic search. I'll just give you a little idea about what we are going to see in the next lecture, which is nothing but a game playing. So what are the things, how this artificial intelligence is been useful in game playing? Because nowadays you find that there are very intelligent games coming out into the picture. So how this AI is entering into this in these games? So we are going to see the two methods under this. One is called as minimax and the other is called as alpha beta pruning. Okay, so this alpha beta pruning and the minimax, these two algorithms actually will help you to understand how the game playing will come into the picture. So let us little bit get an idea about how this game playing will come into the picture when we go with minimax. How this will play. What kind of algorithm is this that can be useful in game playing? So minimax algorithm is a recursive or a backtracking algorithm which is used in decision making and game theory. So very simple. It is a recursive or backtracking. Now हमने backtracking को अच्छी तरह से समझा है. Backtracking algorithm हमने already देखा है. So backtracking algorithm में क्या होता है? वो पीछे की तरफ से नीचे की तरफ से वो ऊपर की तरफ जाता है. एक होता है फॉरवर्ड ट्रैकिंग और दूसरा होता है बैक ट्रैकिंग. बैक जैसे ही फॉरवर्ड और जाता है, एक बार एक पॉइंट की तरफ आ गया तो बैक ट्रैक करके देखता है कि क्या ये नया वाला पॉइंट है या मैं ऑलरेडी विजिट कर चुका हूं. अगर वो विजिट कर चुका हूं तो वो पॉइंट को छोड़ देगा, वापस पीछे की तरफ जाएगा, देखेगा ये पॉइंट पे मैं जा चुका हूं क्या. अगर जा चुका हूं तो मैं वहां पर अभी नहीं जाऊंगा, वो पिक्चर में नहीं आएगा. इस तरह से उस पॉइंट को बैक ट्रैक किया जा सकता है. So obviously it uses the backtracking algorithm that is very much needed in decision making and all the theory that comes under for game playing. It provides an optimal move for playing assuming the opponent is also playing optimally. So obviously it will provide you that step considering the optimum as playing in the same way. So if I am going to play with the computer, whatever I am thinking, the same kind of thing the computer is going to think about me, because he's considering me as an opponent. So whatever the steps that will come into my mind, he'll also go through those steps. Hence it provides an optimal move for the player, assuming that the opponent is also playing optimally. Minimax algorithm uses recursion to search through game tree. So obviously I have said that it's a recursive kind of a technique called as backtracking. And obviously it will be possible only if the whole nodes comes under tree. Minimax algorithm is mostly used for game playing in AI, such as chess, checkers, tic-tac-toe, Go, and various two-player games. So obviously जो आप ये जो गेम्स देख रहे हैं, दिस गेम्स में जो टेक्निक यूज हुई है वो आर्टिफिशियल इंटेलिजेंस बेस्ड है, और उसी में से एक टेक्निक जो है, एक अल्गोरिदम जो गेम प्लेइंग में यूज होता है, वो मिनीमैक्स है. सो ये जो गेम्स आपने अभी देखे ऑन स्क्रीन पे, ये वाले चेस से लेकर टॉप प्लेयर गेम तक, ये सारे एआई बेस्ड गेम्स है और इनमें मिन मैक्स अल्गोरिदम यूज होता है. दिस अल्गोरिदम कंप्यूट्स द मिनिमैक्स डिसीजन फॉर द करंट स्टेट. In this algorithm, two players play the game. One is called as max and the other one is called as min. So why the name is given as minimax? Because as we require two players in the game, hence the name is given as minimax. So one will be called as max and the other one is called as minimum. That is minim. Both the players fight it out as an opponent player gets a minimum benefit, why they get the maximum benefit. सो ऑब्वियसली जब खेल खेला जाता है तो ये मैं चाहूंगा हमेशा कि मेरा वर्चस्व रहे और सामने वाला कमजोर पड़े. सो इसी तरह से गेम बनाने की तैयारी की जाती है. बोथ द प्लेयर्स फाइट इट आउट एज द ओपोनेंट प्लेयर गेट्स मिनिमम बेनिफिट. सामने वाले को मैं मिनिमम बेनिफिट दूंगा और खुद मैं मैक्सिमम बेनिफिट लूंगा. एंड द सिमिलर वे द कंप्यूटर इज ट्राइंग टू गेट द मैक्सिमम बेनिफिट considering me as an opponent and giving me the minimum benefit. Both the players of the game are opponent to each other. So obviously I am the opponent to him and he is the opponent for me. Where max will be selected the maximized value and the minimum will be select the minimized value. So obviously both the players of the games are opponents to each other. So how it is going to be calculated, maximum and minimum? So those will take the maximum value, it will have a max, and those who will take the minimum value, they will be having the minimum. The minimax algorithm performs a depth first search algorithm. Obviously देखो अभी आ गया ना आपका सर्च algorithm. So इसीलिए वो ऊपर वाले सर्च algorithms पढ़ने बहुत जरूरी थे. अगर वो समझोगे तो ही आपको ये गेम प्लेइंग वाला एप्लीकेशन समझ में आएगा. So Minimax algorithm performs a depth first search algorithm for the exploration of the complete game tree. So the algorithm of minimum max is obviously based on the depth first search algorithm, that is DFS. The Minimax algorithm proceeds all the way down to the terminal node of the tree, then backtrack the tree as a recursion. ऊपर से ट्री के लास्ट नोड तक वो जाएगा और बाद में बैकट्रैक करते नीचे से ऊपर की तरफ जाएगा. That is the backtrack the tree as a recursion. Hence it is also called as a recursive method or a backtracking method. ठीक है. So working of Minimax we'll see tomorrow. So this is the thing what we have seen.